In this video, we will be graphing and analyzing rational functions such as these. Rational functions are functions that have fractions where the numerator and denominator are polynomials. All right, let's start with problem number 1 here. Now, before I get too carried away, I'm actually going to skip down here to the slant asymptote. Now, a slant asymptote is a diagonal line that the function gets closer and closer to, but never touches. There will be a slant asymptote if the degree of the numerator is 1 more than the denominator. All right, there's like one exception to that rule, but don't worry about that right now. So the degree of the numerator is 3, and the degree of the denominator is 2. Since the degree of the numerator is 1 more than the denominator, there will most likely be a slant asymptote. Now, the way you find the slant asymptote is you go ahead and do division. Now, I'm going to go ahead and do long division. Because it's x squared, you can't do synthetic division. So let's do long division and see what we get. Okay, so here we are set up to do long division. I always check to make sure that nothing is missing. I have 3, 2, 1. I'm looking at the powers. Normally there'd be a constant here. We could probably get by without writing this down, but I'm going to go ahead and write plus 0 just to make it clear that there's one more term of the polynomial. It's a constant term. I'm going to put the 0 there. All right, so now the way long division works is you look at the x squared, you look at the x to the 3rd power, and you ask yourself, x squared times what is going to give me x to the 3rd power? Well, x squared times x will give me x to the 3rd power. So I put that right here. Notice how I line up my like terms. Now, once you have this, you do the distributive property with it. X times x squared, of course, is x to the 3rd power. That's what we wanted. But x times negative 1 is negative x. Now, I'm not going to put negative x right here because it doesn't go with this term. I'm going to put my negative x right here. All right, next we change the signs in order to subtract. So this will become subtraction, and this will become addition. So of course these will cancel each other out. This has nothing to combine with, so I have 2x squared. Here I have negative 3x and positive 1x, so that'll be negative 2x. And I still have my plus 0, which I'll just bring down. All right, and then we sort of start over. All right, so x squared times what will give me 2x squared? Well, obviously that's 2. All right, and you take that and you do your distributive property with it. So 2 times x squared, like we said, will give us 2x squared. 2 times negative 1 is negative 2. And again, don't put it here. Put it over here with the constant column. Okay, now we have to subtract by changing the sign. So I'll make that minus, I'll make this plus. Okay, this would come, these cancel, whoa. These cancel out, this comes down, so I have negative 2x and then plus 2. But see how I have already arrived at my constant? So that means this part is already done. This is the remainder down here, but for finding the slant asymptote, we don't really care about the remainder. I mean, there should be a remainder, but the slant asymptote, if I put a y equals in front of this, this is the slant asymptote. Okay, remember y equals mx plus b? Okay, think y equals mx plus b when you look at this. This is a diagonal line that starts at 2 and goes up 1 over 1. Anyway, y equals x plus 2. So that's my slant asymptote. Let's go ahead and write that down. Okay, y equals x plus 2. And like I said, we can go ahead and graph that. Okay, we'll put a dot at 2. All right, that's my y-intercept. And then the slope is 1, so that means my slant asymptote would go up 1 over 1 like this. All right, so this is my slant asymptote. And it already looks pretty good as a dotted line, but in general we would draw a dotted line through this. All right, now let's go back and talk about vertical asymptotes and holes. Okay, these two things. Now a hole happens when there's a factor in the numerator and the denominator that will cancel out. So to figure out whether or not there's a hole, we need to factor the numerator and denominator. So let's go ahead and do that now. So the denominator, I'm noticing, is the difference of two squares. So x squared minus 1 factors as x plus 1 times x minus 1. Okay, now the numerator. First of all of these have x's. So that's a GCF. There's a common factor. So the first step of factoring is always to pull out the GCF. So I'm going to bring this x outside of parentheses before I do anything else. That's going to leave x squared plus 2x minus 3. Okay, so this is what I'm really factoring when I do the numerator. So I'm going to keep this x out there, but I'm going to take this trinomial and I'm going to try to factor it further. X squared is x times x. 3 can only be 3 times 1. Let's see, to get a positive 2, remember inner plus outer equals middle. Right now inner I have 3x, outer I have 1x, and I need to make a positive 2 middle. So I can get positive 2 if this is positive and this is negative. That would make positive 2. So positive 3x, there's my positive 3. Negative 1x, here's my negative 1. Okay, so now I have factored everything. So these are factors, x, x plus 3, x minus 1, x plus 1, x minus 1. These are 5 factors. If there are factors that are the same in the numerator and the denominator, they will cancel out. And that is what causes a hole in the graph. So normally, and we're going to get to vertical asymptotes in a moment, normally we look at the denominator for vertical asymptotes. So at first glance, if we didn't factor the numerator, we might have thought there are 2 vertical asymptotes. We might have thought there's a vertical asymptote at -1 because of this and +1 because of this. But actually there's only 1 vertical asymptote because these factors cancel out. So instead of a vertical asymptote, we're going to have a hole from this. Now, to find out where the hole is, we set x minus 1 equal to 0. So that gives us x equals 1. So that means the x value of the hole is 1. All right, so there's going to be a hole at 1 comma something. All right, this is an ordered pair. It's a point. We're going to graph it as an open circle. But we need the y value. To get the y value, we're going to put the remaining part of the function in the calculator, or you could do it by hand. You could take this 1 and plug in 1 everywhere. And it would be just as fast if you know what you're doing. All right, but many of you who lack skills should probably just use your calculator. Okay, know thyself, mathematician. So let's see. X times x plus 3. So there's x, and then there's x plus 3 over x plus 1. All right, and we want to know what's happening at 1, so might as well start there. So 1 comma 2 is my hole. Okay, so let's fill that in. So 1 comma 2. So we have a hole at 1 comma 2. So which, by the way, we might as well go ahead and graph that. So 1 comma 2, that means we have a hole right here. So let's make a nice clear open circle at the point 1 comma 2. Okay, So now we can do the rest of the problem. So now let's go back and talk about vertical asymptotes. Vertical asymptotes come from the denominator. But again, if the denominator, if a factor gets canceled out, that's a whole. So my only vertical asymptote is going to come from this x plus 1. Okay, if I set x plus 1 equal to 0, subtracting 1 from both sides, that's going to give me x equals negative 1. So that's the equation of my vertical asymptote. It's a vertical line at negative 1. So I'm going to come over here and draw a vertical line at negative 1. All right, so there's our vertical asymptote at negative 1. So we have all this stuff. So now we're up to the x-intercept. Now, x-intercepts come from the numerator, okay? So it's going to be the zeros of the numerator. And again, you can forget about this part that's been canceled out. Forget about that, all right? That's a whole, that's over with. So for my x-intercepts, I'm going to be looking at this part right here. So if I basically set this equal to 0 and solve the numerator, that's going to give me my x-intercept. So if I set this equal to 0, then see how it has two factors? Then really I'm going to wind up setting both of these factors equal to 0. All right, setting this equal to 0 means setting x equal to 0 and setting x plus 3 equals to 0. Yeah, so x equals 0, that's as far as that goes, all right? That's going to be one of my x-intercepts. And from the x plus 3 equals 0, you know, subtracting 3 from both sides gives me x equals negative 3. So these two values are going to be x-intercept values. So, so just remember that, 0 and negative 3. So 0 and negative 3. All right, x-intercepts are always something comma 0. So this x-intercept is 0 comma 0, and this x-intercept is negative 3 comma 0. Okay, all right, these are obviously going to be zeros because they're on the x-axis. That's a y value of 0. So let's graph them. Okay, so 0 comma 0, that means I'm going to have a point right there. That's an x-intercept. And negative 3 comma 0. That's right here. That's an x-intercept. All right, so we've plotted all these things. So right now, I already have a pretty good idea what this graph is going to look like. With these 2 points right here, I mean, you know, this is a hole, but still. In looking at the asymptotes, I'm betting that I'm going to have a branch like swerving like this, okay, nestled in this corner. And with this 1 point right here, I'm betting the rest of the points are going to fall right along here. But let's go ahead and plot several more points, and we could record them on a table. So we've already got the equation in our calculator. So let's just plot a bunch of points. Now, students will often ask me, how do I pick the points? How do I know what points to plot? And the real answer is, you should just plot as many points as you can. Just plot a bunch of points. I mean, the graph itself is only so big. So you should just plot as a bunch of points until you run out of room. But let me focus on the point that you guys usually will miss. Look at the vertical asymptote. See how the vertical asymptote is at negative 1. Normally students will just stick to integers, you know, whole numbers and the negatives. So students will go 1, 2, 3, 4, negative 2, negative 3, negative 4, negative 5. They won't do any decimals. Now the one decimal that you need, I believe, you should look at the decimals just to the left of the vertical asymptote and just to the right of the vertical asymptote. So I don't care what other values you use, just do a bunch, but make sure if you've got negative 1, if you go just a little bit to the left of negative 1, that would be like negative 1.5. Definitely do that. So like on a table, can I make a table right now? Okay, I don't have a lot of room, so let's see. I'll just make a little, you know what, I'm going to make it vertically. Okay, so on a table, I will definitely do negative 1.5. And if I go just to the right of the vertical asymptote, that would be like negative 0.5. So I will definitely use those two values. So let's see, how do we even do those decimals? Well, my favorite way, okay, if I go table, enter, instead of doing auto all the time like we usually do, I will do ask mode. Hit enter on that guy. Now it's waiting for you to type in whatever you want. So I can type in negative 1.5. And it gives me this, 9 over 2. Now I know that 9 over 2 is 4.5. But if I didn't know, I could just toggle it. Okay, so that gives me 4.5. Okay, what about negative 0.5? Okay, so negative 0.5 gives me this. Okay, and that's negative 2.5. Okay, let's go ahead and plot those points so far. So at negative 1.5, I'm at 4.5. So at negative 1.5, I'm at 4.5. So that'll be right there. At negative 0.5, I'm at negative 2.5. So here's negative 0.5, here's negative 2.5. Okay? Let's just do another point on the left and another point on the right. Okay, so I've got that. Let's find out what's going on at negative 2. Okay, and I'll just continue to use my ask mode. So let's look at negative 2. At negative 2, I've got positive 2. Okay, so at negative 2, we're at positive 2. So that gives me 3 points over here. That's pretty good. Let's go ahead and record that on our chart. Okay, what about at positive 2? It's another value that we need. So let's see, I'll put in positive 2. At positive 2, I've got 10/3, which is 3.3. Okay, 3.3. All right, so let's plot that. 2, 3.3. Okay, so there's 3.3 would be about there. All right, so that gives me plenty of points to show that, you know, I see these 3 points over here. That's showing what's happening over here. These 4 points, including the hole, show what's happening over here. So I'll just go ahead and draw in this curve as best I can. All right, so your graph should look very much like this. Make sure you leave your hole very clear and open. All right, so that is it for problem number 1.